as well as I'm a senior test technologist. I'd like to talk a bit about the natural language processing. How many of you are actually working on natural language processing today? Hands? Nobody? Not one of them? Okay. Yes, this one. So we'll talk a bit about what NLP is and the overall brief test strategies about how to go about it. We'll talk a bit about the challenges involved in the NLP, which is a pretty niche area. We'll talk about it, and then we'll come up with what are the challenges involved and what are the pitfalls involved in testing such an application. So this is a general definition of natural language processing that's available in the web. I like the second one because it specifically mentions about the text and the voice part. It's basically the computer's ability to process the natural language. And so we'll move on to the next slide. So this question I already asked, and how many of you are good at English in terms of part of speech, adverbs, adjectives? 1, 2, 3, okay. How many of you test NLP projects today? None? 1? Okay. So just wanted to get a feel. We'll be looking at the black box approach. We are not going to go into the algorithms of how to process the natural language processing. You know why? Because it's quite complicated and the industry is spread across different kinds of applications, having their own approach of doing the text processing. So we don't want to go into the algorithms as such. We won't be looking at the voice part of it because that's a different, completely different area altogether. And then, so what are the challenges involved in the natural language processing? It's the language construct itself is complicated with a lot of permutations and combinations. Who are all in testing, you're already aware of the number of combinations, right? So there's no need to elaborate on that. And it's even more complicated when you are doing the NLP processing. Even if the input is restricted, we will come to an example later where I will show you how many different ways the same thing can be said in natural language. So that brings in the complexity of how we need to process this. And it's all about the context. The same thing that is said on one context will mean something else on another context. A domain also plays a role. So these are all the complexities involved in processing the NLP. So these are the applications we have in place today. We have document classifications in colleges, hospitals, research centers, where they need to find out what kind of document it is. For example, if you have a hospital where a patient record is there, they have to find out whether it's an asthma case or a cancer case or a diabetes case or whatever based on the text that is present in the document. We have chatbots. Everybody uses chatbot these days. There's no need to elaborate on that. And we have online customer feedback where cases like Amazon and Flipkart, people come and write their feedback in Twitter or Facebook and so on. So broadly classifying the text into two parts. One is the structured text where we need to follow a specific set of rules in terms of the keywords that can be used and the format of the document. That is the structured text part. And also the free flow text part where we have applications where anybody can write anything and it's up to the application to figure out what it is about. So these are the basic two types of text that the application needs to process. Let's look at English briefly as an example. We have the current words that are used in English is 171,476. You can go through these numbers. That gives the complexity of what we are looking at. To give you an idea about the complexity that we are looking at, the combinations of the words, And also the same word can be used in two different contexts that will make an adverb as an adjective or something like that. So you have these different possible combinations, which is making it even more difficult to process the text. To give a brief idea about the parts of the speech in English language, you have 8 parts of speech. The source is given there. You can go through it. The knowledge is very much available in the internet. If you're really interested in finding out all about English, you can go ahead and read about it and get yourself knowledgeable about this. And each word in a sentence can be marked as a POS, and that is the basis of processing a structured text. Just a simple example of a structured text document where you have the tagged text. So this is basically an XML document. So if you have an XML parser, you are all set. But if you want to do this the natural language processing way, it has to be fed into a POS algorithm, and the POS is, every word is marked as a POS, and then the classification is made, and then the processing is done. From a testing perspective, what are the things that we need to be aware of? Can you give me some test cases on this? What are the things that you would test from this example? Anyone? Yeah, please go ahead. Okay. Sure, thank you. So here I would pay attention to the tags, like for example, answer, question, all those things are tags. So those things needs to be processed correctly. Whatever is written in between the tags, they have to be extracted, and that information has to be written somewhere, maybe in a flat file or something. So what is happening between the tags needs to be figured out. The tags have to be recognized. Whether we are really looking at an XML document is something we need to look at. There could be spelling mistakes in the tags. Some of the components could be missing in the document. So these are all the possible combinations as a tester one needs to be aware of when looking at a document. At the end of the day, it doesn't matter whether a parser is doing the implementation or it's a natural language processing which is doing the implementation. Whether your end objective as a business, are you addressing that? Are you able to achieve the things that you want to achieve is what we are looking at. So this is one very easy example that I have taken for the sake of time. There is one more example where we have a first page of a thesis document for a college where you have some of the keywords. The title, department name, all those things could vary, but there are some words which are pretty much common for all the documents. So the objective here is to process this page and figure out and extract the information, and also make sure that everything is in place and there are no errors. How many of you are aware of machine learning, how it works? 2, 3, 4, 5. This is a typical machine learning model where we have a testing set and a training set. This is very, the same architecture is followed in the natural language processing also in case of a free flow text processing where probability is involved. The training set basically stores all the classifications. So if you have a statement saying, for example, today is Saturday, so what is being conveyed here is today is Saturday, so the classification is a weekday or something like that. So you do all the classifications, the correct classifications in the training set. So the training set is the Bible that I would be using. Testing set is something, the real-time data that is coming inside. So when a new text is coming inside, you want to figure out whether it matches with any of the existing entries in the training set. If it's the same, then you can say that the classification is the same as what I had before. If it is not the same, then you find out the nearest match where the probability is involved. And if it is a match, then we say that we have a 70% probability that it's the same entry, and then we provide that information to the user. So we build a training set. The more and more accurate entries we have in the training set, the accuracy increases. Typically in an NLP case, we are looking at more than 90% accuracy for the confidence level, and the training set keeps increasing. In a customer feedback processing case, typically we have around 3,000 to 4,000 entries. In a very domain restricted and context specific case, we have around 3,000 to 4,000 entries, which a typical machine learning algorithm can process, and accuracy is somewhere we are looking at around 95%. And then if there is definitely a domain expert involved who is sitting there and seeing whether the entries are right, it's very difficult to automate this because of the number of combinations, permutations. See, if it is not a classification problem, if you are just looking at clustering it into 4 different quadrants or something like that, it would be pretty easy to automate that. But in this case, we have to be very specific about what we are trying to achieve, what is the classification we are trying to make. So it's definitely a domain expert is needed who knows a lot about the domain and what is being talked about in the text. If it doesn't make sense, the algorithm is going to throw out. So these are the considerations from the testing side about what is involved in the NLP processing. One is working with the domain expert closely on the supervised learning. The domain and context, as I said, it's very important, because if you have a database built for online customer feedback in e-commerce, and if you try to apply that to a manufacturing industry, it won't work. The misses that we have from the testing set has to be reported to the domain expert, and the training set has to be built continuously. Then the tester has the responsibility to come up with commonsensical multiple combination of text. The same text, same what we are trying to say can be conveyed in different ways. So I'm providing an example here. I'll be there on Sunday could be expressed in so many different ways. So the tester has a responsibility to make these entries into the training set so that the classification is correct. The other things that the tester needs to keep in mind is building the training set, the algorithms take time. So how much time does the algorithm take to process the training set and come up with a model? In terms of the machine learning, whether it's 5 minutes, 10 minutes, 1 hour, 2 hours, how much time does it take? This is one of the important performance parameters, because there are several algorithms out there, and there are algorithms which can process the entire training set in 5 minutes, and some algorithms might take, say, 1 hour. So we have to look at the performance criteria when the model is being built. Also, how much time it takes for the testing set. The testing set itself, it might take a lot of time. Whether the training and the testing, the processing and building the model itself is taking place. I have seen algorithms which are pretty good for data analysis. When it comes to the text analysis, it breaks, because let's say, for example, the decision tree, where you have the number of nodes that we have in the decision tree, it exceeds the acceptable number that the algorithm can accept, so it just comes out. So cases like this we have to be careful about it. Whether the algorithm is really able to process the text is something we need to be careful about. Now the nuances and patterns in the text, that's pretty important, because different algorithms have different ways of processing the text. I have seen examples like neural networks, which are pretty good at some of the data analysis when it comes to text processing. I'm not talking about deep learning or something. I'm just talking about plain vanilla machine learning neural networks. There are some cases where the performance suffers. But in case the max entropy algorithm is performing far better. So the ability of algorithm as well as the performance is the key that the tester needs to be aware of. So as I mentioned earlier, it's a black box approach. So you need not worry about the nuts and bolts of how the algorithm is working, what kind of probability calculation is doing, and all those things. At the end of the day, is it giving me the classification within the time frame that I'm looking at, with the accuracy that I'm looking at, is what matters. There are differences in output behavior. If I'm using Python, I might be getting a different kind of behavior. If I use R, I might be getting a different kind of behavior. I have seen things like that. Even though the algorithm is the same, implementation could be different. So these kind of differences has to be kept in mind. Suppose you have implemented, suppose the developer has implemented say in R, and they are tomorrow moving to the Spark platform. They have their own set of libraries. So the library could be different. Even though the algorithm that is being implemented is the same, the library could be different, and it could result in the difference of behavior. So when we are, today especially when we have so many products in the market, when we are moving from one framework to another, or one language to another, we have to be sensitive about how the new platform or the new framework is behaving. So that is something we need to keep in mind. Accuracy of the output, 99 is pretty much we are looking at, 95 is okay, but 99 is what we need to shoot for. We can achieve that by increasing the accuracy of the training set. So all the while I've been talking about the free flow text format. These are all related to machine learning and how the probability is used for the free flow text. Before that I was talking about the structured part, where specific parser or specific structured mechanisms can be implemented to process the text. So we have covered both free flow as well as the structured text. So coming to the headaches. So take time to read through this. This is one of the online customer feedback that is provided in one of the top retail platforms. And you can clearly see what is the impact that it would have on the algorithm, which is either you do it the structured way or you do it in the free flow text. It is very difficult to process. The problems are obvious. I have highlighted that in the red color. There are grammatical mistakes, there are punctuation mistakes, there are wrong word usages. And added to the problem is, the problem that the customer has written here does not map to one specific classification. It is not saying that the product has not come to me. There are multiple problems here in this complaint. One is the defective mobile is received at the first place. The return request was rejected. Another order was placed which is not processed. Service center is not repairing. Too much of time delay and no response from customer service. Everything in the same batch of text. Now even if you use the very complex algorithm which can provide a multi-nodal output of classification or something like that, you will see that it will miserably fail just because of the fact that the text has been written in a very horrible fashion. So what are your thoughts about how to address this problem? Any inputs? Please. Okay. Right, so the keywords are all there. I have the order ID. See the order ID here says I ordered order ID, and then the name of the component. So my keyword is already there. It's just that I highlighted, but generally it will look like all free flow text. You won't be able to figure out. The problem is not the keyword. The problem is, okay, any other attempts on this? How we can make this better as from the algorithm perspective? So if you are a tester who is doing the NLP testing, and if you want to go to the developer and say, hey, I have a better approach to this. Any other inputs?
Give a template to customer. Give a template to customer so that they can give order ID and description to the problem, which will be useful, and from them it will be very useful for us to get the keyword.
Okay, your input, please.
Increasing the test suite and also continuous learning from the past data.
Yeah, so test suite can keep increasing, but the basic approach in which I am trying to solve the problem, if it doesn't change, it doesn't matter whether I have 10 KB of data or 100 gigabits of data.
But we can identify if our algorithm accuracy is below 90%.
Right, accuracy is different. I am talking about the basic approach of the business approach of how we are going to implement this. You are right. When it comes to accuracy, when we decide to do using probability, using machine learning, the accuracy matters. But as a business problem, how are we? So she is right. The way we need to do is we have to provide standard templates. Amazon is doing it today. When you try to submit a complaint on an online order, it will clearly ask what is the subject of the complaint, and once you give the subject, then it goes to the sub topic of what exactly is it, a replacement or return or something like that. So it keeps asking multiple levels of questions so that you can get into what exactly the issue is, rather than giving free flow format to the customer, which is the key for this problem. But unfortunately, many organizations out there are still using free flow text to get the customer problems. So this is exactly what happens. So natural language processing, all those things can be a fancy keyword that we all talk about, but when it comes to writing a real-time application, processing the text, it's very complex and very tedious. I heard a joke recently that one of the developers wrote on Twitter that writing about a chatbot engineer. What was he doing 10 years back? He was writing a chatbot. What was he doing 5 years back? He was writing a chatbot. What is he doing today? He's writing a chatbot. So it will occupy all of your life, and you won't be able to release any version if you keep using the same approach. So the approach needs to change in terms of how we are addressing the problem rather than the technology itself, right? So that is the key point I wanted to make with this particular example. Yeah, go ahead. Yeah, that's what she mentioned. You provide a template. You provide a template asking about what is your order ID. See, in this case, to detect the order ID itself, it will take time for the algorithm, to figure out what exactly the order ID is here in the text, because there is so much of text involved. So give probably a text box where the order ID can be input. Similarly, you can provide inputs and drop down lists for all the key things here, and then you are done. And then finally, if the customer wants to do any additional text, they can enter in some comments, and that can be narrowed down. So that can be processed easily. Typically what happens is it's very difficult to process a paragraph of text. When you really parse it and split it into sentences, it is easier. So that's where the challenge is. Any other question? Yeah, go ahead. Same area. In the customer feedback itself, if you have any other feedback or something like that, you can add those comments, and that can be processed as because it is going to be 1 or 2 sentences or probably 3 sentences. That can be processed very easily. And this is not rocket science. We are not going to we are not going to implement that in an application where you have a very critical application running or something like that. This is a very customer feedback analysis, right? So this is a very standard application. So maybe write 2 or 3 sentences. Maybe that can be taken as customer sentiment or something like that, which can be processed for the future. Current situation itself, we can use it for customer sentiment and customer feedback. Whatever they want to tell, they can tell it in 2 or 3 sentences. Yeah, so just for the sake of time, I think many of you are restless already, need a break. So we'll talk a bit about the chatbots, because we are all using chatbots. So the objective is to show all the possible options to the user upfront, so that they don't need to type so many things and get the system confused. Point the user in the right direction. All intended features should work, and spelling mistakes, grammatical errors should be handled by the system gracefully, and context-specific help and error messages should be provided to the user. So these are all the test side considerations, strategies that we need to keep in mind while testing the chatbots. This is a bad implementation of a chatbot where you have the same error message that is being displayed for all kinds of inputs. There are no options that are being provided. The user is not pointed in the right direction. The same error is being displayed whatever you type. So there is no machine learning, nothing, no processing of text that is happening. And here it's a good user-friendly implementation where specific error message is being displayed to the user, and options are provided at the bottom which you can click using the mouse. That's all I have from my side. I hope you enjoyed my presentation. I thank all the dignitaries and the audience.